Okay, so as we start looking at these gas laws, I just want to remind everybody of the four different variables we have. V is volume measured in milliliters or liters. Temperature needs to be in Kelvin. Pressure, units of pressure tend to be kPa, atm, mmHg, or psi. And if they're not, if we need to convert from one to another, we have these different conversion factors. And then N stands for the number of moles. So if we're solving a problem that involves pressure, we need to make sure that all of our pressures are in the same unit. So we can convert from any one unit into any other unit the way we did in stoichiometry or mole conversion. So as an example, let's say we had 303.9 kPa and we need to convert that into psi. So we would go 303.9 kPa and then make a cross. The word on top goes on the bottom. So there's kPa. We're trying to get to psi, so that's going to go on top. Now from our conversion factors, we know 101.3 goes with kPa. So here's kPa, so I'm going to put 101.3. PSI is 14.7, so I'm going to put 14.7 there. kPa cancels out, and so now I'm left with 303.9 times 14.7 divided by 101.3. So 303.9 times 14.7, whatever that gets, I'm going to divide it by 101.3, and that is going to give me an answer of 44.1 psi. Okay, so now we move into our gas law problem. So the first the formula we're going to look at is called Dalton's. And Dalton's law, John Dalton from the atomic theory, his law of partial pressure stated that if you have a mixture of gases, the total pressure is the sum of all the individual gases put together. So our formula, the P total, comes from adding up the first gas plus the second gas plus however many different gases there are. Only thing we have to keep in mind is all of our pressures need to be in the same unit. So for example 1, what is the total pressure in a container? So we don't know that. That's what we're solving for. That's P total. If gas A has a pressure of 3 atm, so there's our first pressure, we're going to call it P1. Gas B has a pressure of 5 atms, we're going to call that P2. And gas C has a pressure of 44.1 psi, so that's going to be our third pressure. So we know our total pressure is going to come from adding up P1 plus P2 plus P3. Now one thing we notice is psi is not the same as atms on the other gases. So we need to convert psi into atm. So we're going to go 44.1 psi, make your cross, word on top goes on the bottom. So we're going to put down psi. And from earlier, we know from your conversion factors, we know 14.7 goes with psi, and the number 1 goes with atm. So I'm going to put 14.7 psi. Up here is going to be 1 atm. psi cancels out. So 44.1 times 1 is 44.1 divided by 14.7, and that equals 3 atm. That was our P3. So I can plug that in here, and now my total pressure comes from P1, which was 3 atm, plus my second pressure, which was 5 atm, plus my third pressure, which is now 3 atm, and 3 plus 5 plus 3. Our total pressure is 11 atm, and that would be our final answer. Okay, so now if we look at the second example, it says, let's assume there are 4 gases in an air tank. The gases are oxygen, nitrogen, carbon dioxide, and fluorine. The total pressure in a 40-liter tank is 84 kPa. So 40 liters is volume, 84 kPa is pressure, and it said the total pressure. That's my P total. Oxygen has a pressure of 44 kPa, so there's P1. Nitrogen has a pressure of 20 kPa, there's P2. Carbon dioxide has a pressure of 15 kPa, that's P3. What is the pressure of fluorine? That's P4. So we're going to use Dalton's formula. P total equals P1 plus P2 plus 3P plus P4. What do we do with the 40-liter volume? Nothing. It's there to throw you off. We ignore it. So we're going to go P total equals P1 plus P2 plus P3 plus P4. My total pressure given to me in the problem is 84 kPa. My first pressure is 44 kPa. My second pressure is 20 kPa. My third pressure is 15 kPa. And my fourth one, I don't know. Notice all my units are kPa. Great. We don't have to do any pressure conversions. So my total is 84. If I add up 1 plus 2 plus 3, 44 plus 20 plus 15, that adds up to 79. So 84 is 79 plus the pressure of the fourth gas. So I minus 79 from both sides, and what I'm left with is 5. So the pressure of the fourth one is 5, and it's going to be kPa because that's what all my units of pressure are. Okay, well, I'm now going to flip to the back of that paper, and there we get to something that says Boyle's law. So Boyle's law is the second of the gas law problems that we have, and Boyle's law says if we hold temperature constant, volume varies inversely with pressure. In other words, when the volume goes up, pressure goes down. When the volume goes down, pressure goes up. We saw that in the other video when we had this stick and we hold temperature steady. If I take my volume and my volume goes down, my pressure is going up. If my pressure goes down, my volume goes up. So when one moves in one direction, the other moves in the other direction. So if we take a look at these problems mathematically, our formula is P1V1. So the first pressure times the first volume equals the second pressure times the second volume. So P1V1 equals P2V2. So look at the problem. It says you buy a birthday balloon for your mom at HEB. The balloon has 30 liters of helium. What does liters stand for? That's the unit of volume. So we know 30 liters is my first volume. I'm going to call that V1. At a pressure of 1 atm. It says pressure, and I know atm is a unit of pressure. So that tells me that's pressure, so that's P1. You walk outside, let go of the balloon, goes in the air. What will the volume be? So they're asking us about V2 because we already had V1, so they're asking about V2. When it reaches an altitude, that means height. When it reaches a height that has a pressure of 0.25 atm. Atm is a unit of pressure. I know that is P2. So what variables do I have? All I have is pressure, volume, pressure, volume. Therefore, I have to use Boyle's law. P1V1 equals P2V2. Notice my pressure units are both atm. Great. Don't have to do pressure conversions. So now we just plug and chug. My first pressure is 1 atm. My first volume is 30 liters. My second pressure is 0.25 atm. And my second volume, I don't know. That's what I'm solving for. So 1 times 30 is 30. 0.25 times V2 is 0.25. I need to isolate V2, so I'm going to divide by 0.25 on both sides. And when I do that, 30 divided by 0.25 is 120. So V2 equals 120. V, volume is a measure of liters, so 120 liters. Okay, our second Boyle's problem, a 45 milliliter sample of gas. 45 milliliters, that stands for volume. Milliliters is volume, so there's V1. Collected at a pressure of 190 kPa. It tells me pressure, it has kPa, which is a unit of pressure. That's how I know 190 kPa is P1. If the pressure is increased to a final pressure of 260 kPa, pressure kPa, I know this is my second pressure, so P2. What is the new volume? That's V2. All I have is volume, pressure, so I'm going to be using P1V1 equals P2, V2. I'm going to plug and chug. My first pressure is 190 kPa. My first volume is 45 milliliters. My second pressure was 260 kPa. My second volume, I don't know. Units of pressure, both the same, that's great. So now I need to multiply 190 times 45. So I'll break out the calculator here, and we're going to go 190 times 45, and that gives me 8550. So I got 8550 on the left, and on the right side, 260 times V2. That stays as 260 times V2. How do I isolate V2? I need to divide by 260 to get rid of it. So those cancel out. I'll divide by 260 on the left. And 8550 divided by 260 is going to give me an answer if I round it to approximately 32.9. Now, what did we solve for? We solved for volume. Our volume was measured in milliliters, so this answer is going to be in milliliters. Okay, if you do not have a calculator, you can use a calculator as on your phone. That works great. Just go to on your computer. You could go to Google and just type in calculator and use that calculator is there, or you might have an app, calculator app downloaded if you don't have a calculator at home. So there we have 4 different practice problems, 2 problems over Dalton's, 2 problems over Boyle's law, and then your assignment to complete is going to be 4 problems, and they're going to be scrambled. So you're going to have to go through and identify what the variables are to figure out the law to use, and then go ahead and solve for them and submit those via Google Classroom.